Today I'm here to present our work, InNeRF360, text-guided 3D-consistent object inpainting on 360-degree neural radiance field. This is a collaborated work by Dongqing Wang, Dr. Tong Zhang, Ala Aboud, and Professor Sabine Soustong. The goal of this project is that given an input neural radiance field and a text instruction to remove a specific part in the scene, we want to be able to remove the instructed object and leave a visually plausible region. Some of our prior work only works with frontal-facing scene and requires a hand-annotated mask as input. Other prior work on editing 360-degree neural radiance field have difficulty in selecting specific object based on text instructions due to the implicit nature and lack of semantics embedding in the underlying representation. What makes this problem so challenging? Firstly, obtaining a consistent segmentation for object across 360-degree viewpoint is difficult, as the outline of the object changes drastically from different camera viewpoint. Secondly, it is also challenging to fill in the missing region in a visually plausible manner after removing the object. Since the 2D image inpainter has no 3D knowledge, it produces different per frame inpaintings. In this work, we propose our solution to each of the two challenges. Firstly, we introduce our multi-view consistent segmentation module. We initiate a set of bounding boxes with an object detector through the input text prompt and the source dataset images. We then refine the prompt used by the segment anything model through the estimated depth information of the original scene to encourage a consistent segmentation of the model. We use 2D image diffusion to remove the object with our consistent segmentation from previous stage and initialize a new scene in which there will be artifact floaters accumulated by the inconsistent 2D edit, as the diffusion model does not have 3D consistent understanding. We then fine-tune the new scene using our geometric prior. It is a 3D diffusion model trained on ShapeNet and has the prior knowledge of the density distribution of 3D surfaces to remove floaters and fill in the missing region. And at the same time, we fill in the color in 3D space with perceptually consistent appearance inpainting. We qualitatively compare our results to the recent 3D segmentation method SpinNeRF and the video segmentation method Dino, which is considered to maintain some consistency for objects in adjacent frames. For the top row, as the less challenging case, each method gives relatively consistent masks. For the bottom row, however, Dino and SpinNeRF produces incomplete segmentation for challenging cases. On the other hand, our method maintains consistent masks. Our baseline contains artifact in the region with removed object, while our method synthesizes artifact-free results. We also preserve the surrounding background closer to the original scene. Here are some results of our method on 360-degree scenes. Here are some results of our methods on frontal-facing scenes. We show the effectiveness of our geometric prior on removing the floaters in the inpainted region. We can see that the LPIPS loss can improve blurry background output due to the inconsistent 2D inpainting. With our accurate selection and the 3D priors, extension to editing object appearance in 3D is natural. As shown here in our example, we can do much better fine-grained edit compared to the prior work. Thank you for your attention. I have presented our work, InNeRF360, text-guided 3D consistent object inpainting on 360-degree neural radiance field.